All right, hi guys, I'm Layne. I'm from Connext. I'm one of the co-founders, and I'm here to talk a little bit about interoperability and the new protocol we just launched on mainnet that helps bridge EVM-compatible chains. So first, this statement shouldn't come as a surprise to anybody. Ethereum L2s need interoperability. This is going to get worse as different chains launch, different rollups launch. So I think Boba just launched, but you also have Arbitrum and Optimism and BSC and Matic and, Polygon, all these different chains where you can actually see the EVM is becoming more of a standard for, or an API layer that different blockchains can use. But if they aren't able to interop with each other, then we're not going to get the digital money future that we all want. So there's a bunch of different ways you can go about creating interoperability between these environments. In general, there's three main strategies. Native cross-chain validation. So some examples of this are the near Rainbow bridge and any other bridges that actually do block header verification. That is super cool, super awesome. IBC has it as well, and it's really relies on the consensus layer. The problem is it can be really expensive and really difficult to build. You have, on the other end of the spectrum, the POS or proof of stake or multi-party computation MPC bridges. Some examples of those are AnySwap, Thorchain, the Matic POS bridge, and these bridges work by essentially you deposit some funds into a contract, a set of validators validates that that has happened, and they'll mint you some funds on the corresponding receiving chain. These bridges have really excellent UX, and they're awesome, but the problem is they have added an additional trust layer or trust assumption where now you have to trust the people who are validating the deposits that have happened into that bridge. So whether it's the Matic POS bridge validator set or the Thorchain validators, all of these people are now essentially in control of the funds that you've deposited within the bridge. Then you have things like atomic swaps or one-to-one swaps, and this is where our protocol falls in, where things like hop fall in. The really nice part about this is that you don't add any additional trust assumptions, so you just have a liquidity provider who's willing to front the funds on some destination chain in exchange for taking the funds on the origin chain. And it works pretty smoothly, but it can be a bit more difficult to build, and the UX can be less desirable than the MPC bridges. So there is a fundamental trade-off when you're talking about interoperability, and that trade-off is you can't have interoperability without either introducing a trusted third party, so these MPC bridges or things of that nature, or having an implicit synchrony assumption, which means that any transfer that you're doing across chains would have to complete in a certain timeout, and you assume that it's going to happen within that time, or it's not going to happen at all. So we fall into the latter category, as does Hop and Matic or any Thorchain, AnySwap, any of those bridges introduce a trusted third party. And this is kind of a good mental model to ground yourself in and use your intuit about when you're thinking about the trade-offs of different bridges within your system. So we chose to go with one-to-one swaps and have an implicit synchrony assumption. All of our transfers have timeouts, and I'm just going to explain a bit about how our protocol works. It's called NXTP for Non-Custodial Cross-Chain Transfer Protocol. It's a bit of a mouthful, but we couldn't think of anything catchier. So you have two participants in this system, a user and a router. And the cross-chain transfer starts by the user broadcasting and starting an auction. And this auction just says, hey, I want to transfer this asset to this chain, and I'm willing to accept like this amount of slippage. So the slippage can include fees or can include pricing variations. That'll come in a bit later. And then the routers listen to this message and they respond with their own bids. So multiple routers will respond to the user. The user then selects the winning bid, usually based on which is the cheapest. If there's many routers that come in the same price range, then it'll just randomly select from the available ones. Once the router and the user have been paired up, the user will submit a transaction to chain, and this transaction locks up the user's liquidity on the origin chain, and then an event is emitted that the router listens to and then knows that the user has locked up their liquidity and it's time for the router to lock up its liquidity on the destination chain. The payloads between these two calls are exactly the same, so it makes it really easy to reason about and implement, quite frankly. And then an event is emitted that the user is listening to, and the user says, great. The user then signs the payload for the transaction, broadcasts that signature, and is able to claim the funds on the destination chain. Once the signature is revealed, the router can, through the event, the router can catch this event and execute the same transaction on the origin chain and claim the funds that the user locked up. Super easy, super fun to reason about, simple. Oh, okay, sorry. So one of the things you can do with this system that's really cool is you can execute gasless cross-chain calls. So a couple of use cases that come to mind are, I have all my funds on Polygon because there were some really sweet yield farms, and I need to mint an NFT on mainnet. But I don't want to actually move all my funds to mainnet because that's expensive. So I can use NXTP to execute that call without moving any of my funds back to mainnet. Another example is there's this hot new chain opening up. They've got a bunch of liquidity mining opportunities, and I have never been on this chain before, and I need some of the native asset. So you could use NXTP to get your funds over there and exchange, say you're transferring USDC or something, and exchange some of that USDC for the base asset so that you're able to interop on the chain, or farm on the chain without having to get any extra funds for gas. So how that works is you have a user who decides that they want to mint an NFT on mainnet. So, and they have all their funds on Polygon. They prepare with encrypted call data and a fee to incentivize someone else to send the transaction on the destination chain, and for the liquidity provider to actually provide the liquidity needed to execute this call in the first place. So the transaction goes through the router, and then the router will call fulfill, which executes mint using the encoded call data. The user reveals this call data when they call fulfill, and that is passed on through and executed on mainnet without the user ever having to move their funds. And instead, they just pay a relayer fee and a fee to the router for providing this service. So now I want to talk a little bit about some of the improvements that are coming to the protocol in the near future. So one thing that we're most excited about is what we call virtual AMMs. And there is this problem in bridges of this nature where the router liquidity can get imbalanced. To be a router in this system, you usually need funds on both the origin chain and the destination chain. But if there's a lot of demand for transactions only going to one chain, your exit liquidity on that chain is going to be very quickly depleted, and you're going to have a lot of funds on some chain, and soon enough, you're not going to be able to serve the transactions, and you're going to miss out on all the fees that you could have gotten. So we need a way to create an incentive for people to balance out the transaction flow so that the router's liquidity stays balanced on each chain. And a perfect model that comes to mind are AMMs. So we can create an AMM that will price the liquidity available on one chain against liquidity available on another. And if that liquidity starts to get imbalanced, users will actually be able to make a profit by sending transactions in a specific direction. So if you have an instance where you're seeing a lot of transaction volume go to a specific chain, like Optimism, then the price works out so that you're able to create an arbitrage opportunity between Optimism and, say, Arbitrum, where people are incentivized to capitalize on that opportunity by transferring in the other direction, and then the router's liquidity ends up balancing out. So how does that work in the system? Well, it actually fits in really well in the auction process. So if a user wants to go from Arbitrum to Optimism, they start an auction, all of the routers bid, and the routers bid will contain information about the price that the user is getting based on the relative liquidity amounts on each side of the trade. So here you can see that the user gets all of these options, and they select the router with the best price, which is router 3, and then they're able to transfer across chains, and the router benefits because they're able to have liquidity balanced across all of their trades and not miss out on any opportunities. So yeah, then I just wanted to mention we have a provide and Connext bounty, but I think Kyle is best to talk about that.
Sure, yeah. So we've been working with Connext for how long has it been, Layne? Some years. Yeah, Connext rocks. Layne, great presentation. It's been cool to see Connext mature with the ecosystem. I mean, they're really driving, I think, a lot of maturity in the L2 space. Layne, you're going to be on that panel tomorrow. I forget what time it is. There's an L2 panel tomorrow evening. Do you know what time it is? Like 4:15 tomorrow. Layne will be there. I'll be there. Come check that out. We think the opportunity for the hackathon. So provided we're going to put a $1,000 bounty on Connext and base ledger. Essentially, we want to create a router that settles on mainnet. If someone develops, for example, something that listens to base ledger transactions and essentially creates rollup proofs as a result of those transactions, and then pushes them into a router, that would be a really cool hackathon project. Does that make sense? Yeah. Layne and myself, again, David, Myra, those would be some of the folks you would want to talk to about that. The bounty will be posted on the hackathon bounties list pretty soon. And yeah, thanks, Layne. Good stuff.